In question 1, part A, we have to express 16x squared minus 24x plus 10 in the form 4x plus a whole squared plus b. So to express this, we can use a comparison method. Expanding this 4x plus a whole squared, we'll get 16x squared plus 2 times 4x times a, which will be 8ax plus a squared and plus b. And this is equals to 16x squared minus 24x plus 10. Now comparing the coefficients of x on the right hand side, that is equals to 8a, and on the left hand side, that's equal to minus 24. So a will be equals to minus 24 upon 8, which is equals to minus 3. To find the value of b, the constant on the right hand side is a squared plus b, and on the left hand side, it is equals to 10. So now substituting the value of a as minus 3 whole squared plus b equals to 10. So b will be equals to 10 minus 9. So b will be equals to 1. So we can write the final answer as 4x minus 3 whole squared, and b is plus 1. So this will become a plus 1. In part B, it is given that the equation 16x squared minus 24x plus 10 equals to k, where k is a constant, has exactly one root. We have to find the value of the root. Now to find the value, first we need the value of x. Now if we have an unknown constant, we can use b squared minus 4ac to find this value of k. So this will become 10 minus k equals to 0. So using b squared minus 4ac equals to 0, we'll get b is minus 24. So this will be minus 24 whole squared minus 4 into a, which is 16, into 10 minus k equals to 0. 24 squared, if you substitute this in the calculator, is 576. Minus 4 times 16 times 10. So 4 into 16 into 10 is 640. So this is 640, and my 16 times 4 times minus k will become a plus 64k equals to 0. So 576 minus 640 will be minus 64 plus 64k equals to 0. 64k will be equals to positive 64. So k will be equals to 1. Now, once we have the value of k, we can factorize the equation to find the value of x. So the equation was 16x squared minus 24x plus 10. And this was minus k, so this will become a minus 1 equals to 0. So we'll write 16x squared minus 24x plus 9 equals to 0. Factorizing this using our calculator, we'll get the value of x as 3 upon 4. In question 2, the graph of y equals to f of x is transformed to the graph of y equals to 2 into f of x minus 1. We have to describe two transformations which have been combined to give the resulting transformation. Now, if we have y equals to f of x and it becomes y equals to 2f of x, that would mean it has been stretched in the y direction by a factor of 2. So we can write there has been a stretch in the y direction, and the scale factor will be equals to positive 2. And if we have a function, let's say y equals to f of x, and it becomes y equals to f of x minus 1, it means that there has been translation in the x direction of unit 1 or a vector 1 and 0. So this will represent a translation, and the translation vector will be 1, 0. So these two transformations have been applied to make f of x is equal to y equals to 2 into f of x minus 1. Now, it doesn't matter in which order we put them. We can put translation first and then stretch, or stretch and then translation. It will still result in y equals to f of x being transformed into 2 into f of x minus 1. In part B, the curve y equals to sine 2x minus 5x is reflected in the y-axis and then stretched by scale factor 1 upon 3 in the x direction. Now, when a curve is reflected in the y-axis, basically this means that the x values become negative. So if we have y equals to sine of 2x minus 5x, after a reflection in y direction, so reflection in y-axis basically makes, let's say if we have y equals to f of x, it becomes y equals to f of minus x. So in place of x, we'll replace it with a negative sign. So this will become y equals to sine into 2 minus x minus 5 into minus x. So we can write it as y equals to sine of minus 2x plus 5x. And then it is stretched by a scale factor of 1 upon 3 in the x direction. So for stretch in the x direction, we know that if you have a function f of x, so let's say if you have a function f of x and it is stretched in the x direction by a scale factor of a, so this becomes f of a upon x or x upon a. So in this case, as the scale factor is 1 upon 3, so the x will multiply by 3. So if it is 1 upon a, so this becomes a 3. So if I want to write the scale factor as 1 upon a, so this will become a multiplied by x if the scale factor is 1 upon a. And this was if the scale factor was positive a. So now the scale factor is 1 upon 3. So this will become y equals to sine into minus 2, and this will multiply by 3. So this will become a minus 6x plus 5, and this x will also multiply by 3. So 5x times 3 will become 15x. So the final answer will be y equals to sine of minus 6x plus 15x. In question 3, the equation of a curve is y equals to x minus 3 into square root of x plus 1 plus 3. The following points lie on the curve. The non-exact values are rounded to 4 decimal places. In part A, we have to find A, giving answer correct to 4 decimal place. So to find K, we'll substitute x equals to 2 into the equation. So and y will be equals to K. So y will be equals to 2 minus 3 into square root of 2 plus 1 plus 3. So y will be equals to 2 minus 3, which will become minus 1, multiplied by the square root of 3 plus 1 plus 3. So square root of 3 will become 1.73 times minus 1. And when we add 3, the answer will be y equals to 1.26794. So rounding it off to 4 decimal places, this will become 1.2679. In part B, we have to find the gradient of AE, giving our answer correct to 4 decimal place. So to find the gradient of AE, we'll simply apply the formula y2 minus y1. So as K or y is equals to 1.2679 in point A, so that will become 3 minus 1.2679 divided by 3 minus 2. So 3 minus 1.2679 becomes 1.73205 divided by 1. So the gradient of AE is equals to 1.73205. Rounding it off to 4 decimal place, so the gradient of AE will be equals to 1.7321. Now in part B, it says that the gradients of BE, CE, and DE rounded to 4 decimal place are 1.974, 1.9975, and 1.997. It is asking us to state, giving a reason for our answer, what the values of the 4 gradients suggest about the gradient of the curve at the point E. Now, if you look at point E, the x and the y value is 3, and the gradient of BE, CE, and DE is given. Now we can see that in B, C, D, and E, the x value is approaching 3, and the gradient we can see is approaching towards 2. So we can say that the values of 4 gradients suggest about the gradient at E is that the gradient is approaching 2. So the gradient is approaching 2 at point A, point E, as the x value is going towards 3. So the gradient is approaching 2 at point E. And we can also say that this is as the x values approach towards 3. In question 4, the coefficient of x in the expansion of 4x plus 10 upon x whole cube is p. The coefficient of 1 upon x in the expansion of 2x plus k upon x squared to the power 5 is q. It's given that as if p is equal to 6q, we have to find the possible values of k. Now, in the first step, we'll first try and find the coefficient of x in the expansion of 4x plus 10 upon x whole cube. We will apply the expansion formula, that is a to the power n plus nc1 a power n minus 1 b power 1 plus nc2 a to the power n minus 2 b to the power 2 and so on. Now, as we need the coefficient of x, it means that a must have a power 2 and in the denominator it must be a power 1, so that the term in we get a term in x. So as the power is 3, we can simply apply 3c1. So 3c1, in place of a we have 4x into 3 minus 1, and in place of b we have 10 upon x, which will be to the power 1. 3c1 is 3 into 4 squared, that will become a 16. X squared into this will become 10 upon x. So that so this x and this x square will cancel and we'll get 480 x as our value. So this is the value of p. So p equals to 480. And now in the next part, we have to find the coefficient of 1 upon x in the expansion of, so this expansion is 2x plus k upon x squared to the power 5. Now to find the coefficient of x to the power, so this 1 upon x basically means we are looking for x to the power minus 1. Now if we cannot directly guess how to get x power minus 1, we can use the method where we can just write it as 5cr. A is 2x, so in place of 2x, we can just write x, as we are looking for a power of minus 1. And this will become 5 minus r. And b is 1 upon x square. We can write it as x to the power minus 2 to the power r. And we need x to the power minus 1. As we are just looking to find the term in x power minus 1, we will not be using the constants. So this will become x power 5 minus r into x power minus 2r, which should be equals to x power minus 1. So 5 minus r minus 2r will be equals to minus 1. We compare the powers now. So 5 plus 1 is equals to 3r, or r will be equals to 2. Now we could have directly guessed taking 5c2, but in case we are confused of how to find the term in 1 upon x, we can use this method as well. So now using 5c2, we will get 5c2 into 2x. So this will become so 2x to the power 5 minus 2. So this will become 5 to the whole cube, and this will become k upon x squared to the power 2. 5c2 is 10, and this will be 2 cube is 8. So this will be 8x cube into, so this will become k squared upon x to the power 4. Now we can see that x cube and x4 will cancel out to give 1 upon x, and the coefficient of 1 upon x will be 80k squared. In the question, it said that p is equals to 6q. The value of p was 480. So as p was equals to 6q, we'll write 480 over here is equals to 6. And this was the coefficient of 1 upon x, which was 80k squared. So we'll write 80k squared in place of q. To find the value of k, this will become 480 divided by 80 into 6, which is also 480 equals to k squared. So k squared will be equals to 1. Taking the square root of 1, the value of k will be 1 and minus 1. In question 5, the function f is defined by f of x as 2x squared plus 3 for x greater than or equals to 0. We have to find and simplify an expression for f of x. Now to do that, we will substitute 2x squared plus 3 in place of x in the function f. So in place of x, we'll get 2x squared plus 3. And as x is a whole square, so we'll whole square it. And this will become a plus 3. Expanding 2x squared plus 3 whole squared. So this will become a squared. So this will become 4x to the power 4 plus 2ab. So that will be 2 times 2, 4 times 3, which will become a 12x squared plus 9. And this will multiply. This will be plus 3. Multiplying by 2, we'll get 8x to the power 4 plus 24x squared plus 18 plus 3. Finally, the answer will be 8x to the power 4 plus 24x squared plus 21. In part B, it is asking us to solve the equation f of x equals to 34x squared plus 19. So we'll write 8 f of x was 8x to the power 4 plus 24x squared plus 21 equals to 34x squared plus 19. Simplifying this, we'll bring 34x squared on the left hand side. This will become 8x4 plus 24x squared minus 34x squared will become a minus 10x squared, and plus 21 minus 19 will become a plus 2 equals to 0. To simplify this equation or to solve this, we can first use a substitution where we can write y equals to x squared. So y square will be equals to x to the power 4. Our equation, we can write it as 8y square minus 10y plus 2 equals to 0. Factorizing this through middle term breaking, we'll get 8y square minus 8y minus 2y plus 2 equals to 0. Taking 8y common, we'll get y minus 1 minus taking 2 common, we'll get y minus 1 equals to 0. This will become 8y minus 2 into y minus 1 equals to 0. So y will be equals to 2 upon 8 and y will be equals to 1, or we can write it as 1 upon 4. Once we have the value of y, now we can find the value of x using the substitution. So y was equals to x squared. In place of y, if we can put 1 upon 4 is equals to x squared. To find the value of x, we'll take the square root of 1 upon 4. So x will be equals to plus minus 1 upon 2, as the square root of 1 upon 4 is 1 upon 2. And y was also equals to 1. So we'll write 1 equals to x square, and x will be equals to plus minus 1. But as in the question, it says that x must be greater than equals to 0. So the two values of x will be equals to 1 and x will be equals to positive 1 upon 2. So these will be the final two values for x. In question 6, the points A and B have coordinates 8, 3 and P, Q respectively. The equation of the perpendicular bisector of AB is y equals to minus 2x plus 4. We have to find the values of P and Q. Now let's assume that we have a line A and B. The coordinates of A are 8, 3 and the coordinates of B are P, Q. The perpendicular bisector will pass exactly through the midpoint, and from the equation, which is y equals to minus 2x plus 4, the gradient of the perpendicular bisector, we can see it is minus 2. As the two lines are perpendicular, it means that the gradient of AB will be a negative reciprocal. So we can say that the gradient of AB will be a positive 1 upon 2. In the first step, we can make the equation for the line AB. And if we can find this midpoint, then using the midpoint formula, we'll be able to find the value of P and Q. So the equation of the line AB will be y minus y1. So we have the point 8, 3. So this will be y minus 3 is equals to 1 upon 2 into x minus 8. We can write this equation as y is equals to 1 upon 2x minus 8 upon 2, which is 4 plus 3. And simplify it to write it as y equals to 1 upon 2x minus 1. Now to find this midpoint or the point of intersection, we'll solve the two equation, the equation of AB and the equation of perpendicular bisector simultaneously. So the equation of the perpendicular bisector was y equals to minus 2x plus 4. And the equation of the line was y equals to half x plus minus 1. Solving them simultaneously, we'll first take the LCM. So this will become minus 2x plus 4 is equals to x minus 2 upon 2. Cross multiplying, we'll get minus 4x plus 8 is equals to x minus 2. Taking the x on this side, we'll get minus 4x minus x is equals to minus 2 minus 8. Minus 5x will be equals to minus 10 and x will be equals to positive 2. Once we have the value of x is 2, we can find the y value. Substituting x equals to 2 into this equation, we'll get 1 upon 2 multiplied by 2 minus 1. So the y value will be equals to 1 minus 1, which is equals to 0. So 2 comma 0 will be the midpoint. Now once we have the midpoint, which have coordinates 2 comma 0, we can now apply the midpoint formula. So the midpoint formula is x1 plus x2 upon 2 comma y1 plus y2 upon 2. Now the midpoint over here is already given to us, which is 2 comma 0, and the point P and Q is unknown. So we can write this as 2 comma 0 will be equals to 8 plus the x2 value will be P upon 2 comma, we can write it as 3 plus y3 plus Q upon 2, as the y2 value is Q. So we can now equate 2 with 8 plus P upon 2. So this will become 8 plus p upon 2 is equals to 2. Cross multiplying 8 plus p will be equals to 4 and p will be equals to minus 4. And to find the value of q, we will equate 0 is equals to 3 plus q upon 2. So 0 equals to 3 plus q upon 2. This will become 3 plus q equals to 0 and q will be equals to minus 3. In question 7, the point A has coordinates 1, 5 and the line L has gradient minus 2 upon 3 and passes through A. A circle has center 5, 11 and radius root 52. We have to show that L is a tangent to the circle at A. Now, if you want to show that L is a tangent to the circle at A, it means that, let's say this is the point A and the line L is a tangent, which means if we find the gradient of AC, point A and C, it should be the negative reciprocal of the gradient of line L, as this line has a gradient of minus 2 upon 3. So if the gradient of AC is 3 upon 2, it means that line L will be a tangent. So the center is 5, 11 and point A is 1, 5. Finding the gradient of AC, we'll get 5 minus 11 is equals to divided by 1 minus 5. This will become 6 upon, so this will become minus 6 upon minus 4, which is equals to positive 3 upon 2. Now, as they are negative reciprocals of each other, basically this represents that the line L, this line L is perpendicular or is a tangent to the circle with center 5, 11 and radius root 52. In part B, we have to find the equation of the other circle of radius root 52 for which line L is also a tangent. Now, this basically means that, let's say this was the first circle and this was point A and this was the tangent. It means we have another circle for which the tangent is line L at the point A, and we need to find the equation of this circle. So let's call this circle as Q and this circle was P. We already had the coordinates of the first circle, which was 5, 11. The point A will be the midpoint of the two centers, and we already have the coordinates of point A, which were 1, 5. To find the equation of the circle, we need this point, let's say center point x, y. As 1, 5 is the midpoint, we'll apply the midpoint formula, which is midpoint is equals to x1 plus x2 upon 2, y1 plus y2 upon 2. So we'll take x1 as 5 and x2 will be x, the center coordinate for q. So this will become 5 plus x2 upon 2, this will become 11 plus y2 upon 2 equals to 1, 5. Now equating the two equations, we'll get 1 is equals to 5 plus x2 upon 2. So 5 plus x2 upon 2 will be equals to 1. So the x coordinate will be 2 minus 5, which is equals to minus 3. For the y coordinate, we'll write 5 is equals to 11 plus y2 upon 2. So y2 will be equals to 10 minus 11, which is equals to minus 1. Now writing the equation of a circle, the center points are minus 3 and minus 1. The equation of circle is given by x minus a whole square plus y minus b whole square equals to r squared. As a and b are centers and the coordinates are minus 3 and minus 1. So this will become x plus 3 whole squared plus y plus 1 whole squared equals to square root of 52, as the radius is square root 52 whole square. So this will just be equals to 52. In question 8, the first, second, and third terms of an arithmetic progression are a 3 upon 2a and b, where a and b are positive constants. The first, second, and third term of a geometric progression are a 18 and b plus 3. We have to find the values of a and b. Now, in an arithmetic progression, two consecutive terms have a common difference. So if I subtract the second term, which is 3 upon 2a, from the first term, which is a, it will be equal to the difference of the third term, which is b minus the second term. Simplifying both the sides, we'll get 3a minus 2a upon 2 equals to 2b minus 3a upon 2. The 2 and 2 will cancel out. We'll get a equals to 2b minus 3a. We can write this as 4a equals to 2b. And we can simplify this to write it as b will be equals to 2a. For a GP, two consecutive terms have a common ratio. So if I divide the second term by the first term, so the second term is 18 and the first term is A, it will be equal to, if I divide the third term B plus 3 by the second term. Now we already know that B can be written as 2A. So we can write this equation as 18 upon A is equals to 2A plus 3 upon 18. Cross multiplying will get 2A squared plus 3A is equals to 324. We can make a quadratic equation to write it as 2A squared plus 3A minus 324 equals to 0. Factorizing this using our calculators, we can substitute the values of A squared coefficient A, the coefficient of A and the constant term in our calculators to get the value of A as A minus 12 and A plus 27. As A has to be a positive number, it means that the value of A will be equals to 12. Once we have the value of 12, we can find the value of B as B equals to 2A. So B will be equals to 2 times 12, which is equals to 24. In part B, we have to find the sum of the first 20 terms of an arithmetic progression. So the sum formula for an arithmetic progression is n upon 2 into 2A plus n minus 1 into D. Now the first term was A and the second term was 3 upon 2A. So these were the first and the second terms. As A was 12, we can say that B will be equals to 3 upon 2 times 12, which will be equals to 18. So as the first term is 12 and the second term is 18, the common difference will be 18 minus 12, which will be equals to 6. Now we can substitute this in the formula to find the sum of the first 20 terms. So for the sum of 20 terms, this will become 20 upon 2 into 2 into 12 plus 20 minus 1 into 6. We can simplify this to write it as 10 into 24 plus 6 times 19. Substituting this in the calculator, the sum of the first 20 terms will be equals to 1380. In question 9, the diagram shows part of the curve with the equation y square equals to x minus 2 and the lines x equals to 5 and y equals to 1. The shaded region enclosed by the curve and the lines is rotated through 360 degrees about the x-axis. We have to find the volume obtained. Now to find the volume obtained, first we need this point of intersection of the line y equals to 1 and the curve. Once we have this point of intersection, we can use the limits 5 and this x coordinate to find the volume obtained under the curve, and then we'll find the volume obtained under the line and subtract these two to find the volume of the shaded region. So the volume formula is integral of y squared dx and the limits, the upper limit and the lower limit. Now in the first step, we'll find the point of intersection as at this point y equals to 1. So the equation of the curve was y squared equals to x minus 2 and the equation of the line is y equals to 1. So in place of y, we'll write 1 whole squared equals to x minus 2. So x will be equals to 3. So we know now that this value is x equals to 3. Now using the volume formula to find the volume under the curve. So volume under the curve will be equals to integral of y squared. Now we already know that the y squared value is x minus 2. So this will be x minus 2 dx and the limits will be 5 and 3. Integrating x minus 2, we will get x squared upon 2 minus 2x. Once we have integrated, we'll substitute the upper and the lower limits and subtract them to get the volume under the curve. So substituting 5, you will get 25 upon 2 minus 2 into 5 minus substituting 3, we'll get 9 upon 2 minus 2 into 3. We can simplify this to write it as, so this will be 25 upon 2, which is 12.5 minus 10 minus 9 upon 2 is 4.5. So this will be 4.5 minus 6. 12.5 minus 10 is 2.5 minus 4.5 minus 6 is minus 1.5. So this will become 2.5 plus 1.5, which is 4. And we also add a pi to the final answer. So this will become 4 pi. Now for the volume under the line, we'll get, so for volume under the line, that will be equals to, the equation of the line is y equals to 1. So we'll write it as 1 whole squared dx, and the limits are again 5 and 2. Integrating 1, we will get x, and now the limits we'll have to apply. So, and we'll also have to add a pi to the answer. So applying the limits 5 and 3, we will get 5 minus 3. So this will be 2, and we'll add pi to the final answer. So this will become 2 pi. So for the volume of the shaded region, we'll just simply subtract the two volumes. So the shaded region will be equals to 4 pi minus 2 pi. So the final answer will be equals to 2 pi. In question 10, we have to prove the identity 1 plus sine upon 1 minus sine minus 1 minus sine upon 1 plus sine as 4 tan upon cos. So in the first step, we can just simply take the LCM in the denominator. So that will become 1 minus sine and 1 plus sine. So taking the LCM, this will become 1 plus sine into 1 plus sine, which is 1 plus sine whole squared, minus this will become 1 minus sine whole squared. Expanding the bracket, this will become 1 plus 2 sine plus sine squared, minus this will become 1 minus 2 sine plus sine squared. And the denominator, we can apply the algebraic identity, which is a minus b and a plus b is equals to a squared minus b squared. So we can write this as 1 minus sine squared. Expanding the bracket in the numerator, we'll get 1 plus 2 sine plus sine squared minus 1 plus 2 sine minus sine squared. So simplifying this, sine squared and sine squared will cancel, 1 and minus 1 will cancel. So the numerator will be 4 sine, and in the denominator, we'll have 1 minus sine squared. Now, as we need a term in cos, so 1 minus sine squared is equals to cos squared, as sine squared plus cos squared is equals to 1. So we can write this as 4 sine upon cos squared. Now, as you also need a tan in the numerator, we can write cos squared as cos multiplied by cos. Sine upon cos becomes a tan. So this will become 4 tan x upon cos x. In part B, we have to solve the equation 1 plus sine upon 1 minus sine minus 1 minus sine upon 1 plus sine equals to 8 tan x. Now we know that this was equals to 4 tan x upon cos x. So we can write 4 tan x upon cos x will be equals to 8 tan of x. Cross multiplying, we'll get 4 tan x is equals to 8 tan cos, bringing the 8 tan cos on the left hand side. So this will become 4 tan minus 8 tan cos equals to 0. Now, one very important thing to note is that students tend to cancel these tan over here, which will result in a loss of a value. So we'll first factorize and then solve to find the values of x. Now, taking tan common, this will become 4 minus 8 cos equals to 0. So one of the values of x will be tan x equals to 0, and the other value will be 4 minus 8 cos x equals to 0. So cos x will become equals to 1 upon 2, and tan x is equals to 0. So tan inverse of 0, in this case, we'll get an answer x equals to 0, and cos inverse of 1 upon 2 is equals to, so as we have to give our answer in terms of pi, taking cos inverse of 1 upon 2, the answer will be 1 upon 3 pi. As we cannot go beyond 1 upon 2 pi, so these will be our final two answers. In question 11, the gradient of a curve is given by dy dx is 6 into 3x minus 5 whole cube minus kx squared, where k is a constant. The curve has a stationary point at 2, minus 3.5. In part A, we have to find the value of k. Now, when it talks about a stationary point, it means dy dx equals to 0, and the x coordinate is 2. So we can write this expression as 0 is equals to 6 into 3 into 2 minus 5 whole cube minus k into 2 whole squared. Simplifying the bracket, this will become 6 minus 5, which is 1 whole cube minus 4k. So we can write this equation as 4k will be equals to 6, and k will be equals to 6 upon 4, which is equals to 3 upon 2. In part B, we have to find the equation of the curve. To find the equation of the curve, we'll integrate the expression for dy dx. We'll first write this as dy equals to 6 into 3x minus 5 whole cube minus the value of k is 3 upon 2 x squared dx. So we'll bring the dx on this side before integrating. Now integrating both the sides, so integrating dy, that will become y. This will become 6 into 3x minus 5 to the power 4 divided by the new power, which is 4, and multiplying it by the derivative of 3x minus 5, which is equals to 3. Integrating 3 upon 2x squared, this will become 3x cube, and we'll divide by the new power, which is 3, and we'll add a plus c. The 3 and 3 will cancel. This 3 will cancel with 6, and this will become 1 upon 2. So we'll get y equals to 1 upon 2 into 3x minus 4, 3x minus 5 to the power 4 minus x cube upon 2 plus c. Now to find the value of c, we'll substitute the value of x and y. So the y value is minus 3.5 and the x value is 2. So this will become 3 into 2, 6 minus 5 to the power 4 minus 2 cube, which will become 8 upon 2 plus c. So we'll get minus 3.5 is equals to 1 upon 2 minus 4 plus c. 1 upon 2 minus 4 is minus 3.5, as 0.5 minus 4 becomes minus 3.5 plus c. So when the minus 3.5 goes on this side, this will cancel and c will be equals to 0. So the final equation will be y equals to 1 upon 2 into 3x minus 5 to the power 4 minus 1 upon 2x cubed. In part C, we have to find d square y upon dx squared. So the expression for dy upon dx was equals to 6 into 3x minus 5 whole cube. So this was 6 into 3x minus 5 whole cube minus kx squared. So this will become, as k was equals to 3 upon 2, so this will become minus 3 upon 2x squared. To find d square y dx squared, we will differentiate the expression again. So d square y dx squared will become 6 times 18 into 3x minus 5 to the power 2. And we'll multiply it by the derivative of 3x minus 5, which is 3. Minus, so this will become 2 times 3, 6 upon 2, 3x, as the power will decrease by 1. So this will be the expression for d square y upon dx squared. We can simplify it to write it as 54 into 3x minus 5 whole squared minus 3x. In part D, we have to determine the nature of the stationary point at 2, minus 3.5. So for the nature, we'll substitute the value of x equals to 2 into d square y upon dx squared. If it is a positive, it is a minimum point, and if it is a negative, it will be a maximum point. So we'll write it as 54 into 3 times 2. So this will become 3 into 2 minus 5 whole squared minus 3 into 2. So this will be 54 into 6 minus 5, which is 1 whole squared minus 6. As this value 54 minus 6 is greater than 0, it means that the nature will be a minimum point. Question 12. The diagram shows a cross section of 7 cylindrical pipes, each of radius 20 centimeter, held together by a thin rope. The center of the outer pipes are A, B, C, D, E, and F. Points P and Q are situated with straight section of the rope meet the pipe with the center A. In the first part, we have to show that angle PAQ is equals to 1 upon 3 pi radians. Now, one of the ways to show this is that as there are 6 circles around the center circle and they are symmetrical, so the total angle of a circle is 2 pi. So we'll divide this angle by 6, which will give us 1 upon 3 pi radians. Another way is that, let's say if I draw a line from A to F, and then another line from A to the center point of this circle, and then another line from the F to the center point of this circle, we can see that each of these lengths will be equal, as the radius is 20, so each of these lengths will be 40 each. Now, as they're equilateral, so the total angle in a triangle is pi radians, so we can use the equilateral triangle method as well. So if I use the equilateral triangle method, each angle will be pi upon 3 radians. Now, as this is 20 and this is 20 and the angle is pi upon 3, which means that if this length is 20 and this length is 20, this angle will also be pi upon 3. In part B, we have to find the length of the rope. So the length of the rope is the rope is around this whole shape. Now we can divide this into 6 different parts. So let's say each circle will have a sector. So we can make a line to make a sector for each of these. So let's say if I make a line around each of these circles, I will have six sectors, and each of these sectors will have an angle of pi upon 3, and the length will be 20 centimeters. So making a sector around each of these circles, I will have a total of 6 sectors. We can first find the arc length around each of these sectors and then find the straight length rope, the length of the straight lines. Now the arc length is given by the formula S is equals to R theta. The angle R is 20 and theta is pi by 3. So that will become 20 pi upon 3. As there are 6 arcs, so the total arc length will become 20 pi upon 3 multiplied by 6, which is equals to 40 pi. Now, for the straight length of the rope, we can see that the length from A to this point will be 20 plus 20. So this whole length will be 40, which means that the straight lengths or the straight lines each have a length of 40. So we'll multiply this 40 by 6, which will be equals to 240. So the total length will be equals to 40 pi plus 240 centimeters. In part C, it is asking us to find the area of the hexagon A, B, C, D, E, F, giving our answer in terms of root 3. Now, to find the area of the sector A, B, C, D, E, F, we can make first straight lines to join each of the centers to make a hexagon. So we have joined ED up here, we have joined BC, we can join EF, and then finally we'll join CD up here to make a hexagon. Now, once we have made the hexagon, we can divide it into 2 parts. So let's remove these lines. If I draw a line to divide it into 2 parts, we can see that they're forming 2 trapeziums. And each of these trapeziums will have a parallel length, 2 parallel lengths. So one of the parallel lengths will be 20 plus 20. So the upper length, in this case, will have a length of 40 centimeters. And as each of these lengths, this is 20, this is 20, and the diameter is 40. So the total length up here will become 80 centimeters. And this length is 40. So we have the length of the 2 parallel sides. To find the height of the trapezium, we can use sine or cos or tan, but as the hypotenuse over here, the length from A till F will be 40, as the radius is 20 and its angle is pi upon 3. So to find the height, we will use sine theta. So the height of the trapezium will be sine of pi upon 3 is equals to h upon 40, which means that h will be equals to 40 multiplied by sine pi upon 3, which is root 3 upon 2. We can write the height of the trapezium as 20 root 3. Now finding the area of trapezium, that will be equals to 1 upon 2 into the sum of parallel sides, which is 20 plus 40 multiplied by 20 root 3. And then the total area will become 2 times this answer. So this will be 2 times 1 upon 2 into, so this was, one of the lengths was 80 and the other length was 40. So this will be 120 multiplied by 20 root 3. 2 and 2 will cancel. 120 times 20 will become 2400 root 3 centimeters squared. In part D, we have to find the area of the complete region enclosed by the rope. Now we already have the area of the trapezium, which was in between. Now to find the remaining area, we can see that we'll have 1, 2, 3, 4, 5, and 6 sectors. And 6 sectors, and there will be 6 rectangles, as we have one rectangle up here, the second one, third one, fourth one, fifth one, and sixth one. Now each of the rectangles have this length as 40, and as this length is the radius, which is 20. So first, finding the area of one triangle. So area of a rectangle, sorry, it will be a rectangle. So that will be 40 multiplied by 20, which is equals to 800. And then area of 6 rectangles will be equals to 800 multiplied by 6. So that will be 4800 centimeters squared. Now finally finding the area of each sector. So area of a sector is given by the formula half r squared theta. So we know that theta in each case is pi by 3 and the radius is 20. So the area will be 1 upon 2 into 20 squared into pi by 3. Simplifying this will become 400 pi upon 6. And as there are 6 sectors, so the area of 6 sectors will be equals to 400 pi upon 6 multiplied by 6. Cancelling this, the total area of the 6 sectors will be 400 pi. Finally, the total area for the region enclosed by the rope will be equals to the area of the hexagon that we found in the previous part, which was 2400 root 3, plus the area of 6 rectangles, which is 4800, plus the area of 6 sectors, which is 400 pi centimeters squared. We can substitute these values in the calculator and give our answer in 3 significant figures. So the final answer will become 10,200 centimeters squared.